Hello and welcome to today's Glencoe Algebra 2 lesson. Today we're going to focus on section 1-1, expressions and formulas. So we're going to start with some definitions first. We're going to first define the word variable. The word variable in math is any letter usually that's used to represent any unknown quantity. So any letters in a math sentence that are used to represent unknown quantities. Letters representing unknowns. Okay, variables are important. A lot of times we're going to substitute things in for different variables or be asked to find a specific value for a variable. So variables are going to be important moving forward. An algebraic expression is any math sentence that contains at least one variable. Okay, so a math sentence that has a variable in it, something like 5x plus 2. The x in there is the variable. It's a letter that represents some unknown quantity, and the entire thing together is considered an algebraic expression. And for right now, finally, the operation. Any mathematical operation is basically math. The simple mathematical operations that you should be very familiar with are adding or subtracting and multiplying or dividing. Very basic operations are just the math that you're going to go ahead and do. And so we're going to talk about doing the math today, which means that the order of operations is very important. You should probably have heard of this before. PEMDAS, or Please Excuse My Dear Aunt Sally, is the mnemonic device that's often used to help remember the order of operations. And the order of operations is just what it sounds like. We just talked about that an operation is adding, subtracting, multiplying, and dividing. And so what order do you do them in when you have many of them in the same math sentence? So let's just get these down here. The P stands for parentheses. The parentheses step is often one that is a little confusing. Parentheses means do any math that's located inside of parentheses. So for example, if 5 plus 2 was inside parentheses like this in your math sentence, you would add those together first and replace that set of parentheses and the 5 plus 2 that's in there with the number 7. Parentheses, or usually sometimes you might hear the word groupings. Okay, so things that are grouped together, there are some special cases where some things are grouped together, and we're going to talk about those as we go through. Exponents is next, so parentheses followed by exponents. Exponents. Exponents are powers. Things like 5 squared. After you take care of parentheses, then you're going to raise things to powers. Second power, third power, multiply it by itself twice, multiply it by itself 3 times. Exponents is next. And then MDAS means take care of your multiplication, followed by your division, followed by addition, and finally subtraction. It is important to point out that multiplication and division are partner operations, and they can kind of be handled in one step. You would multiply or divide, and the same thing with addition and subtraction. But the multiplication and division must happen before the addition and subtraction. And of course, as you're following the order of operations, if one of these or many of these steps are not there, then you skip over them and you move on to the next one. So order of operations is what we're going to focus on here at the beginning. And so let's look at an example. Here is example 1 from page 5 of the textbook. Example 1 says we're going to evaluate the math expression m plus the quantity of p minus 1 squared when m is equal to 3 and p is equal to negative 4. So the first step that we need to do is we need to first put all of our numbers in. So we're going to substitute m and p out and put in 3 and negative 4. So I'm going to rewrite the expression as 3 plus, parentheses, negative 4 minus 1 quantity squared. And so now what we need to do is we need to actually evaluate this. When we say evaluate in math, we just mean go ahead and do the math. Actually add, subtract, multiply, divide, square something. Whatever the operation happens to be, we're going to go ahead and actually do the math. So we're going to start here with, well, let's jot it down on the side here. P-E-M-D-A-S. And we need to start with parentheses first. So we do have a set of parentheses. That set of parentheses does in fact contain a mathematical operation that we need to first do. So we're going to go ahead and do that first, and we're going to rewrite this again as 3 plus, now inside the parentheses we have negative 4 minus 1. If you have a calculator handy, if you need to do that, feel free. Negative 4 minus 1 would be negative 5, and then that is squared. Okay, so we handled the P. The parentheses portion is taken care of. Now we're going to look and see, are there exponents? Indeed, there is an exponent. We have something that's being raised to the second power, so we're going to go ahead and do that. And this power is outside of our parentheses, so everything inside the parentheses has to be raised to that power. So if you're using a calculator, make sure you include the parentheses when you're doing this. Negative 5 times negative 5 is 25, so we can go ahead and rewrite this as 3 plus 25. That means our exponent step is taken care of. Now I don't see any multiplication or division to worry about in this case, so I'm going to go ahead and skip those and come right down here to addition. This should be our last step, and we can say that 3 plus 25 is 28. And 28 is going to be our final answer for this particular example. So as you can see, we went step by step from P to E, skipped M and D, and then used A to add as our final step to get our final answer. And we evaluated this expression when M is 3 and P is negative 4 to find out that the answer is 28. So let's move on. And here are the guided practice questions from the example 1. I think you should pause the video here, take a minute, go ahead and try them. The answers will be presented toward the end of this presentation so that you can check your answers. I do want to point out here that this symbol right here is not an addition symbol. It is a little cloudy. It is a division symbol, so that is divide. Go ahead and pause the video now and give these two a shot. Okay, so hopefully you took the opportunity to pause the video and try those out. Let's move on to example 2. And in example 2, we're going to start to see some more higher level stuff. We're going to bring in some more operations, and we're going to get to kind of see one of those special cases. So example 2 here says a plus b squared times the quantity of b minus a. And it's asking us to, again, evaluate, which means plug in these values and actually do the math for the value a equals 5 and the value for b equals negative 3.2. So first we're going to go ahead and rewrite the expression with the given variables substituted in for their numbers. So we're going to write 5 plus negative 3.2 squared times the quantity of negative 3.2 minus 5. Decimal point a little bigger there, and close our parentheses. So again, let's jot these down over here. P-E-M-D-A-S. And let's go through and start with parentheses. Is there a set of parentheses that contains math? So what you'll notice is that there are two sets of parentheses. There's a set of parentheses right here and a set of parentheses right here. Now, one of those sets of parentheses contains math, and the other one doesn't. There is no mathematical operation to do inside the first set of parentheses. We will have an exponent, and we will have to do something with that. And that set of parentheses I put in there to make sure that when I square this quantity, I remember to include the negative sign. Okay, that's going to need to be negative 3.2 times negative 3.2, so we need to make sure to remember that. We're going to start with the big set of parentheses, this one right here. So parentheses, negative 3.2 minus 5 is going to be a value negative 8.2. So we can write this out. 5 plus negative 3.2 squared times 8.2. Okay, so the parentheses step is completed. Now we're going to go ahead and take care of our exponents. So in this problem, we do have exponents. We have negative 3.2 squared. I can punch that into my calculator, and I find out that my new expression is 5 plus the quantity 10.24. That's negative 3.2 squared. And that I'm going to need to, whoops, I forgot my negative sign here. That I'm going to multiply by negative 8.2. Okay. Exponents are taken care of. Next, we're going to handle our multiplication. So 10.24 times, put this nice little dot here, times negative 8.2. When we do that step, we find out that this is 5 plus the value negative 83.968. So we've taken care of multiplication. There is no division. And we have an addition or subtraction, kind of depending on how you want to look at this. We're either adding a negative, or we could just look at this as subtraction. But either way that you do it, 5 plus negative 83.968 means our final answer is negative 78.968. Negative 78.968 is our final answer for this. We've evaluated the expression for the values a equals 5, b equals negative 3.2. Now, again, what I wanted to point out here and what you need to watch out for are the way that those parentheses are presented. So, again, we had two sets of parentheses. This one here was there to make sure to ensure that we included the negative sign when we squared, and the other one was a set of parentheses that contained math that we had to do inside of our parentheses as part of our first step in the order of operations. So let's move on, and I want to now look at the special case that I mentioned when we talk about parentheses. So here's an example where we have a fraction. This is a big fraction. The order of operations is going to be very important here. Again, we're going to evaluate, and we're going to evaluate for the values w equal 4, x equals negative 3, and y equals negative 5. Okay, so I want to address first that special case. If you recall from our definition of the order of operations, when we talked about parentheses, I also mentioned the word grouping. So there are actually two big groupings here that you need to watch out for. So this special case that I mentioned is that when you have something that's fractional like this, and you have this line in the middle here indicates that it's fraction, which indicates division, right? So we're going to divide the top by the bottom. We actually have a big set of parentheses on top. That's one group, and even if the parentheses aren't there, as they are not shown in this problem, you need to remember that you need to treat the top and the bottom as if they have parentheses around them, and you need to evaluate each of them first. So we actually want to get to the point where in this problem we'll have a number on the top and a number on the bottom, and we want to then divide them if we're going to do division. We'll talk about fractions versus decimals at a later time, but for now we need to make sure that we recall that those top and bottom groupings count as if they're in parentheses even when it's not shown. Okay, so we're going to go ahead and we're going to fill in our numbers that we're going to substitute in for our values and rewrite the equation. I'm going to include the parentheses so that we don't forget about them. So we have negative 3 raised to the 4th power minus 3 times w is 4 times y is negative 5. And that whole top is in this big set of parentheses right here. And then we're going to go to the bottom. Let's fill the bottom in. We're going to have the big set of parentheses, negative 5 raised to the 3rd power plus 2 times w is 4. And again, that is all inside this large set of parentheses. So now we can go ahead and we can start to do the math that's in the parentheses. Now this problem is important because inside the parentheses there's more math. it's not just a set of parentheses where we're going to add two numbers or subtract two numbers. There's actually addition, multiplication, and in both of these cases some exponents. So once we go inside the parentheses, for each set of parentheses, we then need to apply the order of operations again. So for the top, let's make a little notation here. For the top, we have to follow, please excuse my dear Aunt Sally. So let's look at the top. At the top, parentheses, there are no additional parentheses in there. I suppose that there are, but there's no math inside those parentheses, so we can cross that one off. There are exponents. So our first step is going to be to handle the -3 raised to the 4th power. And I'm going to slide down or over this way. Let's do this. And we're going to do -3 raised to the 4th power. It's the first thing that we're going to do. -3 raised to the 4th power is actually the number 81. Okay, so that turns out to be 81. Inside that set of parentheses, we're going to put the subtraction here. And now we're going to, we handled our exponents, handle our multiplication. Multiplication is next. 3 times 4 times -5 is the value -60. -60. So I'm going to do -60 just like that. And notice I did put it inside a set of parentheses so that we keep straight that we are subtracting a -60. So now we need to do the same thing on the bottom. On the bottom, inside the parentheses, we have an exponent. -5 raised to the 3rd power is the value -125. And to that, we will be adding 2 times 4, which is pretty simple, the value 8. So we have handled the exponents, the multiplication inside our parentheses on both the top and the bottom. And so now we can look at our addition and subtraction point. So on the top, 81 minus 60 is the value, or I'm sorry, 81 minus -60 is the same thing as 81 plus 60 is the value 141. And on the bottom we have -125 plus 8, and when we put those together we get -117. And so we have a fractional value here. The fraction indicates that we could divide these, and if we did divide them, then we would get a decimal answer. 141 divided by -117 is equal to 1.2 negative 1.205 and a whole bunch of decimal places after that. It also does turn out that this reduces. So we might simply just want to reduce this and call it -47/39. And in most math situations, you're going to want to go ahead and leave it as a fraction that is completely reduced. So here we saw an example of a problem where inside our parentheses, we had to again apply the order of operations. So once we established our groupings, because this was a fractional question, we had a top grouping and a bottom grouping. Within each grouping, we had to then apply, please excuse my dear Aunt Sally, the order of operations in order to make sure we do these things in the correct order. So let's go ahead and have you guys try a couple of these. Here are the examples that go with example 2, guided practice problems. You'll notice 2C here does in fact have some of that fraction where you're missing the grouping, so make sure you look out for that. Good time now to pause the video and give these 3 a try. Okay, now that you've taken the time to give those a try, remember the answers will be to the guided practice problems will be presented at the end of this presentation. Let's move on, and before we get to our third and final example, we need to, one more definition. We're going to define formula. A formula is a mathematical sentence, so it's a math sentence, that expresses the relationship, writing the keywords here, the relationship between certain quantities to help you find a specific value. For example, you may already know that the area of a circle is equal to pi times r squared. So pi r squared is the relationship between the radius of a circle and this number pi that gives you the area of a circle. So we can use those values, if we have numbers for them, to plug them in and help us find a meaningful quantity like the area. So let's go ahead and look at an example, in example 3, of using a formula, which is basically the same thing as plugging the numbers in and making sure to do the math in the correct order. So in real world example 3 here, we have a problem. The formula for the volume of a cone is V for volume, equals 1/3 pi r squared times h, can be used to approximate the volume of a tornado. Find the approximate volume of the tornado at the right. So we need to first understand, what are these values? Well, as I stated, V stands for the volume, and we have values R for the radius, and h for the height of our cone. So our tornado here in our picture is basically a cone. It has a radius of 75 meters and a height of 225 meters. So if we can take these values, plug them into the formula, and do the math in the correct order, then we should be able to come up with a value for the volume of this cone. We do also need to know that pi is a constant that is equal to approximately 3.14. Your calculator, if you use your calculator, will give you many more decimal places than just the 3.14. So let's go ahead and try to do this. Let's start with the equation. V equals 1/3 pi r squared h. Let's plug our values in. So V is equal to 1/3 of, I'm going to leave this as pi for now, and we can use calculator pi. R squared, 75 squared, times 225. So now we can look at our equation with our numbers plugged in, and we can see which of these operations, parentheses, exponents, multiplication, division, addition, and subtraction, are in our problem, and make sure that we do them in the right order. So if I look here, I don't see any parentheses that have math operations inside of them, so I don't have to worry about that one. I do see exponents. So we have to take care of that exponent, 75 squared. 75 squared is a pretty big number. We're going to write this out. 1/3 times pi times 5,625 times 225, our height. So we've taken care of our exponent, and what I see left is a whole lot of multiplication. 1/3, we can kind of look at that as division. We can save that to the end, and we can divide by 3. But in any case, we're going to do the multiplication first. So I'm going to start with pi times 5,625 times 225 to take care of my multiplication. And I'm going to write this out as, let's see here, I'll use my calculator. Pi times 5,625 times 225 is a big number. 3,976,078, with some decimals after it, 0.202. And we're going to put that all over 3 because, again, this number, 3,976,078, is pi times 5,625 times 225. And I didn't include the division by 3, which is the same thing as multiplying by 1/3. So I could have simply multiplied by 1/3. I did for the sake of this example. Want to add in another step so that our final step is the division step. So if I take this number and I divide it by 3, I get an approximate volume for my answer of 1,325,359 meters cubed. Now, units, make sure that you include units on your answers. This is important. Cubic meters, all of our values were in meters. This is a three-dimensional object, so we need to make sure that we include units, because 1,325,359 cubic meters is a different size, it's a different volume than 1,325,359 cubic feet, or cubic centimeters, or cubic inches. So we need to make sure that we include units in our answers so that we are consistent and we are correctly giving the information that we want people to have when we solve these problems. So let's go ahead, pause the video at this point, try to work out this example from geometry using the formula to help calculate the volume of this rectangular prism. Alright, now that you've taken the time to try that example of using a formula, we can move on and take a look at the guided practice answers. So guided practice answers, 1A you should have gotten 28, and 1B you should have gotten -2. 2A, the answer should have been 22, 2B should have been 0, 2C should have been -23, and the one you just worked on with the formula should have been 28 cubic feet, 28 cubic feet as the volume of that rectangular prism. Feel free to pause the video now to go back and check your answers or fix any mistakes that you may have made. That's it for today. There will be a homework assignment that'll be on the next screen. I want to remind you that you can go to connected.mcgraw-hill.com, this website right here. Using your login that you got in class, you can log in for 24/7 access to the book. Today we talked about section 1-1, expressions and formulas, which is located on pages 5 through 10, and your 10 problem homework assignment is right here, the Check Your Understanding section. Please complete this and bring it to class with you tomorrow. Pause the video now so that it doesn't revert back to the original screen. Thanks a lot, and I'll see you in class.